私は in this.
Amazing. What happened? But what did you say? I'm sorry. Sorry. What? 私は誰ですか？
私はパクホムです。
You're too fast. You're
イムです。
イムです。
イムさん。
ドンチャイ。イムさん。
I can't find イムさん。
ドンチャイ。DUANG。
Oh, okay. But this become イムさん。
で。
Okay. It's totally different, no?
We use our nickname. That one is our real name.
Fine. No
Yeah.
problem. And then,
Okay.
あなたは
Janice.
Janice.
Janice the guy.
Janice, I found it. Janice. Okay, that's good. Janice, I found. And then あなたは
パクホム。パクサピモン。
You can see our name on the slide. If that helps.
It's like
Park
Paksapimon.
Hong.
パクサピモン。
パクホンさん。Okay.
私は実際です。分数じゃなくて。
分数。PON。
Are you in this group?
分数。
Punsu, right?
Yes.
Isn't Anna is easier?
Giselle.
You're Punsu, right?
Yes.
Okay. But also Andy, right?
Yes.
Okay. Okay. Did you change your name from last year? Okay, then.
私はジェンです。บัวชมพู
Oh, you guys' nicknames are completely different.
เดี๋ยวไปเปลี่ยน
Jan
ジェン
Ji.
ทีです
Okay, hi, nice to meet you.
私はエヴァリンです。You are in. You.
That I know. But I don't find. I don't know your real name.
You were in.
Okay.
Yeah.
Okay, good.
Okay.
And another main character is ともこ
Oh, 私は友です。
はじめまして
Nani
And today we have choose to presenting the game
Oh my
Subway
God.
Surfers.
My God. I have to take this picture. What's going on? Oh my God. Oh.
Now let's see
Okay.
what is Subway Surfers game.
Okay. Oh, I know this. I'm used.
Yeah.
How do you know that?
So
How do you find my picture? Oh,
So
no.
first of all, we're going to give you the game descriptions, which we know that most of us already know how to play the games. So it all started with a teenager boy or girl have to gravity on a train, which is illegal. So the police try to catch them. So as he runs from the police, he has to run through the obstacles and collect some items. So the games will end whenever the boys or girl have been collide into a obstacles.
Sorry, you're Pakon, right?
Yes.
Okay.
And this is your role, you have to ask.
Yeah, it's your role.
Is there any physics related to game?
Yes, sir.
Oh, actually, that's the question I was discussing with Boy this morning. Subway, is there any physics?
So firstly, we're gonna talk about momentum.
Okay.
So, what is momentum? Momentum is a product of an object's mass and its velocity. Simply said, momentum is a force gained by motion or by a series of events. P equal mv is the equation for momentum. As either mass or velocity increases, momentum increases.
So you're Chinese, right?
Yeah.
Okay.
So, firstly, we must understand that in Subway Surfer, it's a game, so it's like a closed system, isolated system. So the law of conservation of momentum applies. The law of conservation of momentum states that in an isolated system, the total momentum of two or more bodies acting upon each other remains constant unless an external force is applied. Therefore, momentum can neither be created nor destroyed. As the equation below states, total momentum before is equal to total momentum after.
So what if this boy hit the train?
So the boy will get hurt, and there's some physics involving here. So we're gonna talk about collision. There are two main types of collision in this game, elastic collision and inelastic collision.
Okay.
When the boy hits like a stationary object such as a wall or an obstacle, it's usually elastic collision. As kinetic energy and momentum is conserved, the boy will usually bounce back and fall down. And there's another one, inelastic collision. So when the boy gets hit by a moving train, kinetic energy is not conserved, but momentum is conserved. Therefore, the boy will actually be being thrown back by the train, following its direction towards the screen.
Okay, let's talk about the next magnet. The next topic is the magnet. Oh, what's this? This one.
Okay, you ask.
The magnet is the material or the object that produce a magnet field. This magnet field is invisible but responsible for the most notable property of a magnet, a force that pull on other former magnetic materials such as iron, steel, nickel, cobalt, and attract to repulse other magnets. As you can see this picture, there's two sides, north and south, or plus or minus. If it's opposite, it's gonna be attract each other. But if it's the same size or the same south, it's gonna be not attract to each other.
Okay. Sorry, you your Where did you go? I lost you.
Don't die.
Okay. You're in the Indian. Okay. Sorry.
Okay, as you can see in the game, the magnet is attracted to the coin. It's because the material of the coin made from like copper, balls, cobalt, or nickels. Those material are attracted to the magnet.
Okay.
Yeah. So have you ever think why the most of country use those material to make the coin? Because the material are strong and durable in USA. Like nickel, it has some like unique electrical properties. Therefore, it's an important component to use this distinguish real coin with counterfeit coin when having to use with worthless coin operate the machine.
Okay, so let's talk about common physics that we can see in this game, but we might haven't noticed it. So in this subway game, right, the developer often want user player to get a realistic experience. So gravity in this game is kind of similar with the real one. So all objects, including all characters, subway class, and item, would be subject to gravity, which means that, for example, when all character jumps, all character gonna fall downward to the Earth's surface. So what is gravity? Gravity is a force of attraction. It pulls objects with mass toward each other. The more massive an object is, the stronger its gravity pull. And this is Newton's law of gravitation. F is magnitude of gravitational force attack with between mass 1 and mass 2, which is right here. And when we talk about force, there's something happen with, there's something exit too, which is friction. So friction also impact like how character interact with obstacle in this game. For example, if all characters slide down a subway car roof, right? The friction will exit, and the friction is like between their feet, like all character and the roof surface. And also, you can see here when they skateboard, the friction is exit and is kind of make them slower a little bit when we slide in subway roof.
So now we're going to present the next topic, but let's you guys imagine about following me. So, for example, if you are on a train station, you are waiting at your platform, you are standing still and the train passes you. The train seems fast. And then another situation is that you are walking to your platform and the train passes you in the same direction. It seemed not that fast. And then another situation is you were walking to your platform, but the train passed you in a different direction. It seemed very fast. Why? So it's all related to relative velocity. So what is relative velocity? Relative velocity is all about the reference, frame of reference. So it is the time rate of change of the relative positions of one object respect to another object. It would be easier if we use an example. So we have object A with the velocity A, and object B with the velocity of VB. And we're going to find the velocity of object A related to the object B. So we're going to get the VAB equal to VA minus VB. And this explains why when you are walking past a train in a different directions, it seems faster. And this is another example, which is if the boy velocity is 5 meters per second and the train velocity is 10 meters per second, what is the velocity of the boy respect to the train? You can get v of boy minus v of train. And the train is in the different directions, so you're going to get 15 meters per second.
Is that your picture?
Yes, sir.
Oh.
And
Okay.
then
So I usually give everyone mini homework.
Yeah.
So what happens if the velocity of boy and train is, say, very close to the speed of the light?
Oh.
Maybe can you do a little bit investigation and then put it in a report?
Yes.
Just a little bit is fine.
Yeah.
Okay, good.
Okay, and the next physics that related to subway surf is aerodynamics.
That's interesting.
Yeah, but okay. What is aerodynamics? You might wonder this. So aerodynamics is the way that object can move through the airs. The rules of aerodynamics can explain how the airplane is able to fly. And actually anything that moves through the air is affected all by aerodynamics.
Okay.
So from since a rocket blasting to maybe a kite flying or even the cars riding. Since they are surrounded by air, even the cars also affected by aerodynamics.
So you're Genji, right?
Genji, yes.
Genji, okay, good.
So there are 4 forces of flight in aerodynamics. The 4 forces of flight are lift, wave, thrust, and drag. And this force can make object move up and down or move forward or backward, faster or slower. And the amount of each force compared to its opposing force determines how an object can move through the air. So it can explain how the plane fly. And also when you're running, you also have aerodynamics happen because you run through the air. So here, yes. When you're running.
What are you doing? Oh my God, can you go back? It is a video?
Yes.
Oh, that's
But what if he runs into the tunnel?
I want to hide. Oh my God, did I have a bad hint?
Oh.
Okay, good.
Okay, so let's let's talk about when he runs into tunnels.
Oh, okay. Sorry, you finished?
Yeah.
Okay. So can you investigate a little bit? You talk about when you talk about light, right? Okay. How about what happens if Earth's air density is half? Then what happens to the air pressure? Can you think about it? Okay. Okay.
Okay, so next we're going to talk about
So,
whenever
How
we,
come again?
yes,
Okay.
when we go through the tunnels.
Tunnels.
Yeah, tunnels.
Okay.
So first of all, the picture on the right is where there's different affections whenever the trains are on the open air or in the tunnels or in the railway line. But today I'm going to talk more about the tunnels.
Mhm.
So whenever the train going through the tunnels, they normally going to lower down the speed. But why? These are the 5 explain. So
That's
first,
interesting.
is safety. Of course, we know that with the reduced amount of speed, help improve the safetyness. Second is in visibility. So what is visibility? This is the way we see. Because inside, with the minimum of the light inside the tunnel, it's really hard to see obstacles or stuff inside. So they have to slow down the speed. The third one is ventilation. What is ventilation? Ventilation is because whenever the train goes into the tunnels, the oxygen have been really reduced, which causes the gas. So with the minimum of oxygen and the air in between, it causes that there might be some kind of gas. So we have to lower down the speed to lower down the gas. And the fourth one is noise and vibration. So the noise and vibration is also talk about the pressure wave, because with the noise and vibration, it reduces the amount of airflow, which it improves the pressure wave, and the passenger might have some kind of heard of a noise, or even they might get some hurtness on their ears or feel uncomfortable. And the third one is aerodynamics. So I'm going to talk more about the aerodynamics part.
Okay.
So Janji have already taught about the open air, but I'm going to talk more about the tunnels, which aerodynamics are different in the air and in the tunnels. So with the aerodynamics and the tunnels, whenever the train has entered or exit the tunnels, they have to reduce the speed to reduce the aerodynamic force, because aerodynamic force have much more potential, have much more effect of aerodynamics inside the tunnel more than the open air.
Okay.
And with we slow down the train, it makes a stable and potential stable more because of the change of the airflow. And I'm going to talk more about the aerodynamic drag. It's one of the effects that cause in the tunnels. So what is the aspect of the aerodynamic drag? It is a combination between a friction drag and pressure drag. And in the aerodynamic drag, whenever the train enter or exit the tunnels, there will be more of the fluctuation in the aerodynamics. And it will cause the pressure wave to increases. And also, whenever the pressure wave increase, it is because of the air. Because whenever the train goes into the tunnels, there's much more smaller space in between, which cause a squeeze of the air. And it will turn into a shock wave. And it might cause a discomfort in passenger.
So the pressure wave, pressure is for the pressure drag is from the front of the train?
It it is also related to like the model of the train. Like
Okay.
also because when entering, it's like with the modeling of the train, it will cause different effects.
Okay. So what is the y-axis here? CD?
CD.
Yeah.
It's like like this one is a drag, aerodynamic drag with respect into the pressure rate. Like when it's going, it's like inclined.
Okay.
Yeah.
Can you check how much pressure is going to increase when train with certain speed goes into a tunnel?
Sorry.
I want to know how much the pressure is going to increase when a train goes to tunnel. Or it depends the size.
It depends on the length of the tunnels.
Mhm.
It depends on the size of the train and the motion. I mean the
Speed, right?
the speed and also the
Shape.
model. The
Yeah,
model.
shape of the-
Yeah. So it all depends on how the tunnels are created.
Okay.
Yeah.
Can you check one example? Show one example in the report.
Oh, what's the example in the report?
One example.
Oh,
No, not now.
yeah.
In the report. Is
I
that-
already sent the report.
It is. You just add it and then.
I'll send it again.
Yeah.
Okay, sure.
Sorry, so everyone have to add it or just...
Yes, that's what I'm trying to do.
Okay, sure.
Did I give you a homework? No? Okay. Maybe I'll think about something later. So when we go into a tunnel in a train, we feel like the ears,
Disperse. Yeah.
so the pressure must be increasing, right?
Yes,
So-
it is
so-
because of the pressure.
Right. So I want to know, how much it's increasing. Maybe it's useful to know.
Yeah, I can
Thank
give
you
some
very much.
examples. Okay, so this is like the aerodynamic drag of the tunnels, like the train tunnels equations.
Oh, good. Very nice.
So the F, let me show you. The F is an aerodynamic drag. The C is a time the train have gone through the tunnels, respectively. Yeah. The P is the air pressure. The S is the area of the train, and
Okay.
and then the VTR is the speed.
Okay.
Yeah.
So C is what?
C is the time.
I remember CX is what? Is it time?
CX. It's a time respect for the train. Like, yeah, it's a time. Like the time when it passed through the tunnels. Like the time time length.
Oh, time taken.
Right, going to the tunnel 1 second, 2 seconds, 3 seconds, like this. Is C?
Yeah, the C.
Are you sure? Because usually time people use T, no?
It's like respect to it. Like,
So that doesn't make sense because if it's time, it's 1 second, 2 seconds, 3 seconds, it's proportionally increase the drag, right?
it's a time function. Like,
Oh, it's a function. It's
yeah,
not just time.
it's more like a function, but it's like related to the time.
I'm not sure about it. It's X means the function of position, no? If it's a function of time, it would be T.
I'm not sure, but from what I researched, it said that it's like a function of the time passing through the tunnels.
Okay. Oh, it's the same thing. If the train speed is the same, the time and speed scale is the same, right? Right. I mean, sorry, time and position scale is the same. And then rho is the air density, and then S is what?
The S,
Is area
the
train.
S is the area of the
Okay.
train.
Okay. So the velocity is okay. So the velocity is area. Okay. Density.
Maybe we can look more into it.
Where's the size of the tunnel? It doesn't matter because I can imagine, as you said, if the tunnel is smaller, then probably it's more difficult for a train to go through, right? If tunnel is very big, then it's okay, right? Like if we go to Iran, then the tunnel is very small and traffic jam, right?
Yeah.
So I thought there might be the size of the tunnel maybe in here too.
Not sure about it.
And then this, see the function, so it's not. So, but in the previous one, can you show the graph? The previous one. So this actually, after a certain time, it decreases, right? So maybe when first suddenly increases when the train goes into the tunnel, and after a while, it just it go to equilibrium, and then it's, the train get used to the environment of the tunnel. So this decrease, what can we see in the equation? Like for example, if you go to the next one, equation, then so the rho or S or V is not going to decrease, right? It's the same, right? So they must be C.
Yeah.
So C, how does it, yeah, okay. Can I change the homework? can you change the homework to investigate more detail of the C?
Okay.
How does it change and then why, if you can explain.
Sure. I'll find it.
Yeah, it's very good. Like you're going more detail, right? So that's I like. I mean, this is physics, so
Okay. Sure.
I'm interested.
Okay.
Yeah. Good.
Okay.
Okay, good.
Okay.
Finish.
Yeah. And
Thank you.
next we have
Welcome.
quizzes.
Okay, before going to quizzes, can I give everyone a mini homework?
Yes.
So can you? Sorry, who was the first one? Can you go to the slides again? Go through the slides again. Oh, momentum. Can you investigate what speed train hits the person, and then this person is going to die?
Sure.
Yeah. Okay.
But this person means the boy, and the boy means the boy is
Yes.
you.
Yeah, the boys and you inside.
Fine. Yeah. I think I'm kind of average size, right? So average bone density. Okay, and then who's next? Magnet. Magnet, you talk about coins, right? Okay, these you talk about different materials, right?
Yes.
Which one is going to be more strongly attracted to the magnet, and then why? It's probably related to some, chemical structure. So probably that's not so difficult. It's just rule each other. Okay. And then
Gravitation and friction.
That's gravity and friction.
okay. Okay. That's interesting. So what happens if the gravity is half? Is it easier for can the ball go faster, or what happened to the game if the gravity is half?
Okay, so I think the boy will fall like, how to say, slower. Like,
Okay. Okay, can you add that to the
Okay.
report a little bit?
Yeah,
Okay.
sure.
And then? I already gave you, right? Okay. So everyone got mini homework?
Yeah.
Okay, then we go to quiz. No, no, no. Can we skip this one?
I'm sorry for the report. I mean, the
Yes.
homework.
Yes,
Like, we just put into this same document as report, right?
yes, yes, yes.
And do you want it by like today or
Yeah, 1 week, 1 week.
1 week? Okay,
Mhm.
sure.
What's the game? It's
Subway Surfer.
what happened to tic-tac-toe? You cancel?
Yeah.
Okay, no problem. You want to ask any question, suggestion, or give them homework? That's fine. Okay. Do you have any question to that? Give them difficult questions.
Because you already suggested
Okay.
like about the relative math,
Okay.
like it's already difficult, so I don't know should I.
Okay.
Okay.
Okay, fine. But if you think about that, if you come up with a question, you're welcome to ask.
I'm sorry. Do we have to gather like all questions that we got into our report?
Only ours.
Okay.
Okay. So I scan that thing.
Yes.
Yeah. Cool. I don't like this part of the presentation because it's like a test for me. Can you can online people see this? Okay. Is the program? Okay. I was a little bit disconnected. So I push start.
Yeah, you can go.
So are we going to do this together or individually?
Oh, we're gonna do it together.
Any who like issues?
Write the code to this is and just type the code.
Okay. Ready?
Yes, so I push start.
Okay. This.
Enter a new.
Start.
start?
Yeah, it's already started.
Or how do we come? Wait.
Không, không như vậy đâu. Bên này không? Đâu có tập trung được. Resetting rule. It's either in half or in the like here it has. อีกบ้างนะเพื่อนทำต่อโบสไม่ตรงกับที่คิดเลยอีกบ้างแล้วก็คนกดคุณจะสามารถก็ดูไม่ให้ผมมอง
I finished?
Okay, so it's N, and the person who got the number 1 is Esau. Yeah.
Did you answer everything correct?
I answered the first wrong, but after I finished, they let me answer it again.
Yeah, I'm surprised. I also answered one wrong, but then they asked me again at the end.
Yes.
And the second person is Tomo.
Oh, really? Oh, thank you.
Yeah.
What is this?
Yeah.
Why did you find it? Oh my god.
Okay, we're done. Thank you.
Thank you. So I have a question. One question that I answered wrong is that 2 or 4 aerodynamics will increase, aerodynamical force will increase in a tunnel, yes or no? So, can you explain
We
that?
reduce the aerodynamic force.
Yes.
Because when we enter and we exit the tunnel,
Yeah.
we reduce the speed, the velocity.
Mm.
So the aerodynamic has also decreased. We try to
Actually,
decrease.
Can you show that question? Is it possible? Or is, or is it difficult?
ต่อเครื่องอิ่มแล้ว
Aerodynamic force increases when entering and exiting. Exiting! Okay. So the answer is...
We try to reduce the aerodynamic force, so we reduce the speed,
Okay.
so it reduces.
Oh, but he means like when existing it's increased because like it go up.
I mean, we reduce it, like reduce the speed both when entering and exit. We reduce 2 times, which it causes the aerodynamic force to decrease.
Okay. When you go out, you also decrease the speed?
Yeah. I mean, we're not really decrease the speed, but like, when they exit it, they try to, what is it? Like get it exposed into the open air. So like,
Right.
they kinda, it's not like reduce as much as wind entry.
Okay.
Because, or else if they just go out in the normal speed, it will cause more of the forces
Okay.
and the airflow.
Okay.
So they have to reduce it to reduce the aerodynamic force.
Okay. Good. Any other questions? Okay, there's someone online. Maybe Professor can turn on the microphone, please.
We didn't open the microphone.
Your microphone was on.
What off? Did we?
For the whole time.
What the whole time? I don't think.
It's okay. We
use
also
this
have this microphone, so.
Okay.
Okay. Sorry, I didn't know. I usually ask students to turn on because you guys speak here, right? But then I forgot to ask you, so sorry. but I mean, you can tell me earlier, no? Why he's telling me at the end of the presentation. But anyway, it's turned on, so it's okay. And then, thank you very much for group 10. It was a great presentation. So thank you very much. Okay, then we have 5 minutes break and then we continue the regular lecture. Okay.